guys, welcome back. We are heading into the last part in piston engines, and today we'll discuss something about fuel system. Fuel system. So, fuel system we'll be discussing as well, fuels and mixtures as well. The next video I'll make on mixture strength and grade of fuels. Alright, so this will have two fuel system and also fuels mixture. Okay, so there'll be two topics covered in one video. It's very small, very simple, very theoretical actually. So let's start off. So to supply fuel from the tanks to the engine, high wing, low power aircraft uses gravity feed system. Like the Cessna 152 for example, it is high wing, low power aircraft, uses gravity feed system. What happens in a low wing, like all of our commercial aircraft, low wing or even say aerobatic aircraft, what happens in those is we have something called an EDP. This stands for engine driven pump. Okay, now EDP is also called as EBP, electrical booster pump. Okay, so now what are the features of the EDP or the EBP is supplies fuel under positive pressure. Alright, prevents cavitation. Cavitation is basically the sucking of air. Okay, transfers fuel from one tank to the other. Maybe it is used for priming, and also in case of emergency cases, if an aircraft has two EDPs or two EBPs, then it's used for emergencies. Okay, so that's about this one, and let's go on discussing further. What are these tanks made of? Tanks are made of aluminum alloy or synthetic rubber or nylon bladder. Okay, any one of these. Depends on the different type of aircraft, use different this thing. Most tanks contain vent or breather. If you remember previous videos, I already mentioned what is a vent or a breather. It is used to maintain internal pressure, atmospheric pressure within a given compartment cell. Okay, next, now this is something important here. To prevent surging of fuel during attitude changes, fuel tanks are fitted with something called as baffles. Okay, so I'll draw what baffles are. It's a simple concept here. So suppose this is your tank, fuel tank. Assume it to be a rectangular cuboid. So baffles are something like these structures. Okay, so when your attitude changes, in case the fuel doesn't flow up and down in this, there are baffles, certain restriction compartments kind of a thing, which allow the fuel to flow, of course, but at the same time doesn't allow surging to happen. Okay, then we have sump, drain or fuel drain to remove sediments and water. If you're flying already, you would know that before every morning, the first flight in the morning, and of course after, actually any flight for that matter, under the wing generally it is found a drain sort of system where you plug in a device that drains out down sediments and water. Since water is lighter, so I mean heavier than the fuel, so it just sinks down in the tanks. Even the sediments are heavier, so they're always staying down, so that is used. Now there's something called as a gas collator. This guy here, this system is used to drain fuel completely. Okay, so this is perhaps you could tell it's the lowest point in the fuel system. Okay, it could be near the cowling, so that the whole fuel inside the pipelines and everything just drains. Okay, then there is something called as cross feed. It is in multi-engine aircraft, be it jet engine or prop or anything. So it is used to feed fuel to one tank to any engine, or one tank to any other tank. Okay, it's very important in multi-engine. Cross feeding is quite important. In case of single engine piston like Cessna and Cessnas and these guys, they have something called as interconnect. Interconnect is something, it is a similar concept to cross feed, but it is just in this single engines it is used to transfer fuel between wings. That's all. Then there is something called as jettisoning. It's a process to dump fuel in air. This happens generally in overweight aircraft. Long haul distance flight have this jettisoning process, that in case their engine fails or something of that sort happens, if they have to return back to the same airfield, they can dump fuel, eject fuel. Okay, fuel quantity gauges are set up for each tank separately because they different. Then there is something called as a totalizer. As the name suggests, gives total fuel on board. Basically just adds up the values of the each gauge. Okay, another important point, fuel tanks are topped full at night. Why is this done? Is to avoid condensation, to prevent condensation of the humidity at night. When temperatures go down inside the tank, if there is humidity, of course, that to prevent condensation, basically, if the answer is to prevent condensation. So the humidity that is there around inside the tank, so it might just condense due to the temperatures being low at night, so that will settle down as water inside the tank, and that is not really desirable. Then there's a concept called priming. So it is the process of supplying raw fuel for a cold start. is used in cold countries mostly, and even in winters in tropical countries as well, where there's temperatures are low. What happens if you overprime? Overpriming leads to pre-ignition, overflow because you've given too much fuel, and also backfiring. The engine will backfire. Okay, so that's about basics about fuel system. I think that's more than enough, and let's move on to fuel and mixtures. So let's start with the simple concept about hydrocarbon. What is hydrocarbon? Hydrocarbon is a combination, it's a chemical thing which has hydrogen and carbon in it. Now hydrocarbon is basically our fuel in this case, and if you add fuel with air, what are the components that come out? Are CO2 and water vapor. Water vapor here also mean exhaust gases. It comes on the whole thing is exhaust gases, of course, but CO2 is a major component. Basically the idea of this equation is, if you have fuel, that is hydrocarbon, if you burn it with air, you will get carbon dioxide and water vapor, and the whole thing is called exhaust gases. Okay, now if you just want me to split it up, I can write hydrogen is 14%, for example, and you have carbon here, that is 86%. Then you have in the air you have 21% of oxygen, and N2 you have 79%. So I mean, these are not exact values, of course. There are different argon, there are many more gases as well, but there's a general split. Okay. Then let's talk about the most important question here, that is calorific value. So it is the amount of heat energy that will be released during combustion. Okay, so it is, the units are, it has, you can have multiple units for it. So let's do the standard one, that is kilojoules per kilogram, or there's something called as a degree CHU per gallon. Now CHU stands for centigrade heat unit. You just have to know this, there's not much you have to remember about it. High calorific value of a fuel means its specific gravity, high specific gravity. So if you have a fuel that is having high calorific value, it means your specific gravity of the fuel is high. Then we have SFC, that is, I discussed this previously as well, specific fuel consumption. This is fuel consumption by brake horsepower. Okay, then let's go on to something as a terminology that is called as volatility. Basically volatility. So what is that? Is tendency of evaporation of a liquid. So if something is volatile, if your fuel is volatile, it's going to evaporate really quickly. So we do not it depends if you want to reduce volatility or you want to increase it. So if you want to make the fuel more volatile, then adding tetraethyl lead, LEAD, not LED, LEAD, lead will make your fuel more volatile. Okay, now what happens is, if you add too much of this, you will have vapor locks and anti-knocking, and sorry, carburetor icing. Yeah. So what happens is, if your fuel is too volatile, it will evaporate quickly. There will be vapor locks in the system, in the fuel system itself, and that will of course lead to your carburetor icing, and which is not really we don't need carburetor to be frozen at any point of time. Then there is something called as anti-knocking property. So how do we measure anti-knocking? Octane value is the measure of anti-knocking. Okay, so anti-knocking property is respective to the fuel. Every fuel has its own octane value, and of course its own anti-knocking property that is linked to its octane value. So higher the octane value of the fuel, higher the compression ratio. Now what this gives us is, if you have higher compression ratio, higher thermal efficiency. Alright, now with that you have higher temperature and pressure during combustion. So this gives you higher engine power output. Okay, so now you can also increase the anti-knocking property again by adding same tetraethyl lead anti-knocking increases. Okay, but it results in excessive carbon release, because if you have too much tetraethyl lead in your fuel, so your spark plug may foul. The very important is what will happen if you keep on trying to increase your anti-knocking. And knocking itself is the engine sound, the knock. So you have to reduce it. So that's why it's called anti-knocking. But if you keep on increasing anti-knocking property, it may lead to fouling of spark plug. Basically the carbon formation on the spark plug. So to prevent that, there's a chemical added called ethylene dibromide. Okay, so this will prevent carbon formation. Alright, next, so in high performance aircraft, if you have a rapid climb going on, rapid climb or rapid descent, so what happens is fuel may not cool down very fast, because you are at a high altitude, your fuel temperatures are freezing, and if you're at lower it's different. And if you have a high performance climb out, rapid climb, so in that case the fuel may just boil. Alright, so in that, what we do is fuel may boil. In case if your fuel is too volatile, it will evaporate very fast. So if you're coming down, and it might just boil really fast. So in that case, what happens is, how do we prevent this? Alright, so we have provisions for cooling the tanks, cooling the fuel tanks. Then you can also pressurize the fuel tank, or of course you can just reduce your rate of climb. That is perhaps the most easiest. Okay, and there's something called, last point here is TSFC. This stands for thrust specific fuel consumption. So this is the amount of this is very important. It's been generally coming around in the exams. So amount of fuel required to produce 1 pound of thrust. So this is very important. What is TSFC? It is the amount of fuel required to produce 1 pound of thrust. Okay, normal, this is just an important, you can just note it down for your reference. Rate of burning of fuel, that is normal rate is 60 feet per second, and detonating rate, which is not desirable, is around about 1000 feet per second. That's just you can just note it down for your knowledge purposes. Okay, so that's all we're done for this video. We're done with fuel system and we have done with fuels and mixtures. I think you guys have hopefully understood and extracted something out of this. Do take the short quiz so that it will you know, you can assess yourself that you have understood something that I've just taught you here. And next we're gonna do is mixture strength, and we're gonna do grade of fuels, and after that will be carburetor, and we'll be done with piston engines. Alright guys, I think that's it for now. If you've liked the video, please do share it, like it of course, subscribe to the channel, yes, and like the Facebook page. The quiz link is on the description, and spread a word, okay? Alright, see you guys, bye bye, take care.